Problem 9 is asking us to determine the amplitude, the period, and the phase shift of each function, of the function, and then graph it. So amplitude is always my first number, which in this case is 3. My period is 2 pi over b. B is the number in front of theta or x, so I substitute in 3 for b. And my phase shift is the number after theta or x, so in this case it is right pi. So for me, the easiest thing to do is to actually make an input-output table to help me ascertain what the points are going to be. So I like to start with 0. At 0, I would get 3 times 0. So 3 times 0 is 0. 0 minus pi is negative pi. Using my unit circle, negative pi is going to be the same as 270 degrees. My y value there is negative 1. And then I would still need to multiply that by the 3 in the front of that. So 3 sine 3 pi minus pi at 0 degrees actually happens to be negative 3. So what I would be able to do on my graph is go 0 and put a dot at negative 3. So then I can just start going through and rotating through the unit circle. So the next place I might want to go is pi over 2. So if I plug in pi over 2, I get 3 pi over 2. 3 pi over 2 minus pi would be 2 pi over 2, which is just pi, or 180 degrees. The sign there is 0, and 3 times 0 is 0. So then I do need to change my x-axis to include a pi over 2, and I'm going to put a dot there at 0 for my output. Now from here, I know it's going to be periodic motion, so I can start plotting my points so that every time I go pi over 2 on the x-axis, I'm going to start this periodic motion. So really, at the bottom of my crest, or the bottom of my amplitude or period, I'm going to be here at negative 3. I come up to 0. I'm going to go up to 3, back down to 0, down to negative 3, and continue on in this fashion throughout my rotation around that unit circle. And just getting that sinusoidal curve like that.